Today's lesson is on calculating volume. First, we're going to start about talking about measurements in geometry, which include volume. Then we're going to talk about three-dimensional shapes that have two congruent bases in parallel planes, and those are called prisms and cylinders. Then we'll talk about shapes that I call pointy shapes, which are pyramids and cones. And finally, we'll talk about spheres. And so we're going to start with using measurements in geometry. So geometry is really at the heart of it about measuring things. And so you measure things in distance, how far one thing is from another. So for example, we measure things in nanometers, like how far transistors are apart on chips, or in inches or centimeters, for example, how tall you are, or in miles or kilometers, how far is it to San Francisco from here, or in really large units called AUs or light years, you're talking about how wide is the Milky Way. And in geometry, we have to find the length. So we've seen problems like that where we use our distance formula, or we have to find that length of that missing side. We also have studied in geometry area, or two dimensions. So for example, we use square inches or square centimeters to figure out how big is a piece of paper, square feet to talk about how much carpeting or flooring there is in a room, acres or square miles to talk about how big is California. And we find area problems like this. We have to find the area of that rectangle, of that triangle, find the area of that sector of the circle. And hopefully at this point you all feel very comfortable about all of those different things. And so far this year we spent literally all of our time measuring distance and area. So starting right now, we're going to add the third type of thing we can measure, and that is volume, or things in 3D. So for example, you measure things in cc's or cubic centimeters, like how much medicine do you take? Or in fluid ounces, pints, gallons, or liters, how much milk does a recipe call for? Or in acre foot, like how much water is in the Atlantic Ocean. And in geometry, we're going to be able to solve finding volume problems, like find the volume in that prism, or find the volume in that cone. All right, so now we're going to start talking about shapes with two congruent bases in parallel planes, and those are called prisms and cylinders. And we're going to start with the prism. There are lots of 3D shapes, and we'll start with the easiest, which again is the prism. A prism is a 3D shape with two bases in parallel planes and all the other faces as rectangles. So there is a prism. Those are my bases, those two triangles. All the different sides are called faces, both the what are called lateral faces on the sides as well as the bases are also called faces. The lateral edge is right there, and that's also the height of my prism. And we can also call that height altitude. Okay. And there are lots of different types of prisms, and we name them after the shape of the base. So I mentioned the one over on the right there is a triangular prism. And here are lots of other examples: squares, rectangles, pentagons, hexagons, and octagons as prism. In fact, any polygon at all can be the base of a prism. And if we're going to talk about prisms, we have to talk about, at least mention, the most famous prism of all, the one on the cover of Dark Side of the Moon. Because if you take a prism and you make it out of a clear substance like glass and you shine light into it, it refracts the light into a rainbow like that. Now let's talk for a second about the volume of a prism. So imagine I had a prism that was 4 blocks wide, 3 blocks high, and 4 blocks deep. Let's make a picture and put some colors on it to see what's going on. So there it is, 5 blocks wide, 3 blocks high, and 4 blocks deep. Well, how many blocks are there in such a prism? Well, the formula to find a rectangular prism is we just multiply those. We'd multiply 3 times 4 times 5. And that would give us the volume, how many of those individual little blocks there are. But of course, not all prisms are rectangular. We just went through a bunch of different examples that weren't rectangular prisms, so they're not always going to be that easy. You can just count. But note we could use the formula a little differently because the area of the base is length times width. So we could rewrite this formula as the volume equals the area of the base times the height. And in fact, that's what we're going to use for our volume of a prism. We take whatever the base is of that polygon, whatever shape it is, an octagon, a pentagon, whatever, and then we multiply by the height. So there's our first formula for the day. Next, let's talk about the cylinder. A cylinder is a 3D figure with two parallel circular bases connected by a curved surface. There's a picture of one. And cylinders are very similar to prisms because they also, like prisms, have two parallel bases that are connected. The difference is that in a cylinder, this base is a circle, not a polygon. And of course, there are no faces. The faces are just a curved surface. And I should note that when we're talking about cylinders, we're going to talk only about cylinders with circular bases, but a cylinder also could have an oval base. But we're only going to talk about circular ones. And there's the bases. Because its bases are circles, a cylinder has a radius, and then also, of course, a height. And cylinders are everywhere. We see them all over the place. We see them. Cans are cylinders. Big oil drums are cylinders. Paper roll. Toilet paper is ultimately a cylinder. And my favorite Muppet character, his whole head and body is a big cylinder. That's Beaker. So let's take a look at cylinders, try to find the volume. And let's start by reviewing the volume of a prism. There's my prism, and we said the volume is the area of the base times the height. Well, the volume of a cylinder is very similar. There's my cylinder. Again, it's just the area of the base times the height. The only difference is the shape of the base. That the shape of the base of a prism is a polygon, the shape of the base of a circle, the shape of the base of a cylinder is a circle. And this is why I lump these two together, a prism and a cylinder together, because I don't think it makes sense to have to memorize two different formulas. You just memorize that you take the area of the base times the height, and there you go. And you just have to obviously be able to find the area of different kinds of bases. And so obviously the area of the base for that one would be pi r squared, because that's the area of a circle. All right, let's move on to what I call pointy shapes, pyramids and cones. I'll start with a pyramid. The pyramid is a 3D figure with only one polygon base, and each corner is attached to a single point. Like prisms, there are lots of different types of pyramids, and like prisms, we name them after the base. So there's a triangular, square, rectangle, pentagon, hexagon, and octagonal pyramid. These are all pyramids. And of course, the most famous pyramid, we just call it the pyramid or the pyramids, are the pyramids in Egypt. And you can see at the bottom of those, there's actually people there. It gives you a sense of how big that pyramid is. Now let's talk about the cone. The cone is a 3D figure with one circular base and vertex. And cones are everywhere. So party hats, traffic cones, and of course, everybody's favorite, an ice cream cone, with a circular base all coming to a point. So notice that prisms and cylinders have two parallel bases. They don't end at a point. Right? There's a picture of some. There are no points on those. But pyramids and cones have only one base, and each point on the perimeter of that base is connected to a single point. So for example, like that. And notice that cylinders and prisms don't have a point, but that pyramids and cones have that single point, and that's why I call them pointy shapes. And the reason we lump them together as pointy shapes is because finding the volume of them is the same process. Just like finding the volume of a cylinder and a prism is the same process. So first, to find the volume of a pointy shape, you essentially just assume you go through the same process as if it were a cylinder or a prism. So what you do is first you multiply the base by the shape's height. So again, first you pretend like it's a shape that isn't pointy. And then you use what I call the rule of pointy shapes, which is if it's pointy, divide by 3. So to find the volume of either a cone or a pyramid, you find the area of the base times the height, again just like it was a cylinder or a prism, and then you divide by 3, and that'll give you the volume of any pointy shape. Now we've talked about shapes with congruent bases, we've talked about pointy shapes, and that leaves us finally with spheres. And we all know what a sphere is. It's a three-dimensional object that's shaped like a ball. And we see spheres all the time in everyday life. There's different balls, some foods are spherical, Christmas ornaments, and of course the planet we live on and the star that provide all of our energy are spheres. And a sphere is analogous to a circle. A circle is made up of every point on a plane that's equidistant from a central point. And a sphere is made up of every point in all three dimensions that is the same distance from a center point. So for example, there's a picture of a sphere, and you can see that I have a center, and there's only one radius there, but if I were to do every single radius, every single possible distance from that center point, all the points one radius away would give me a sphere. Now we just have to know the formula for the volume of a sphere, and you just have to memorize it. And the formula for the volume of a sphere is it's 4/3 pi times my radius cubed. Let's try that again. The volume is 4/3 pi times my radius cubed.